Okay, this part is too thick. We're looking at the control block, and the part is too thick, so we're going to have to shell it. And we need to figure out what surfaces need to be left by its function. So what I'm going to do right now is, I believe this slot should be left, and I think that these should be left, right? The counter bore kind of situation. Everything that's a notch I think needs to be left. I'm not too sure that this needs every bit of it left, but by its angle it's going to kind of make it difficult. So the first thing that I like to do is do a draft check, and I'm going to once again go to my selection filter and grab solid geometry and select the entire part. The direction, let's say, is this direction. It looks good because this surface could be pulled out, this surface could be pulled out, and this one from the bottom. So let's look at this direction and see what happens. So if we look at that direction, I see that anything that's curved like this, that's definitely the direction that you want to go. That's already got draft. It's inherently got draft in it. I've got a situation here, though, that I would have an undercut. Let's look at, let's see, this is a front, so let's look at front. And this is another one of those things. But here is the angle. If I were pulling it this way, I could pull this, but if I had steel come down and shut off, I'm going to have a split draft right here. So if I tried to pull all this from this side, I would be obstructed by this. If I tried to pull all this from this side, I might have to split this about some parting line that we may create. So that's the first time that we're going to be doing that. Let's look at the rest of it now. The rest of it looks fairly straightforward. You guys think? This is just a flat. So we're going to have to say what needs to stay consistent and what can change. And that's really where your draft gets tricky. But what's also tricky about this part is how its function is. So how are we going to shell these surfaces? What are the function of this? Is this surface more important than this surface? Can I pull this out from the top? You're going to have an underside here. So it may be better to pull this way with a slide after the fact. If I pull this with a slide after the fact, then I can pull most of this surface with it. Right? So we're going to look at drafting this, shelling this, leaving the top hollow.
I think a lot of it will depend on what it means.
That's exactly right. The comment was made that a lot of it depends on how the part is used in the assembly, or what does it need to mate with. So we're gonna look at this, and we're gonna try and determine it. And because this is at an angle right here, I would think that if we had shelled surfaces right here, it could play as a surface, but then the rest of these surfaces would be whole. So that might be a good way to go. Even if you have a shelled surface, you still have a riding surface if you had something else made it. So, but let's look at the rest of this. This all works fine. Could shell all this. How do I shell the inside of this? It's called coring out something. We're going to core it out. That means that there's going to be an open surface that we're going to remove, right? But we may have to core it out in an odd way. If these are so particular that these surfaces need to be here, then we're going to have to core out this side and leave those surfaces. So making this part as a cored out part may be a little bit harder than the draft even on this one.
Well, it's not very big. It's going to need to be cored. It's going to need to be hollow.
So the question was, is this going to need to be hollow? So if I measure the distance from here to here, that's over an inch thick.
Yeah.
It can't be solid in a PC-ABS blend. Now, if you're going to go with something with thicker walls, you may have to add glass fill or mineral so that you can have those thicker walls. It actually gives it more structure so that it doesn't sink. Right? We're going to talk about that later in the books. So I think we have to core it. The other thing to look at, if you do a measure here in length, and the length of this line that's 227 millimeters. How many inches is that? It's about 10 inches. Yeah, it's 10 inches. So if we drafted it and cored it out from this side only, leaving all those features, there would be an inordinate amount of draft on that. So we're going to have to look at coring this out.
And why wouldn't you core it out from the other end?
This end?
This end.
Because it's 10 inches long,
Okay.
you would have to go around this block. You couldn't pull the steel through there. And in 10 inches, 3 degrees would be really thick.
What
Yeah.
if you were to have the opening in that?
The question was, if we removed the backside and left the walls here, we've still got this situation. So we're going to have to remove this face as well.
Okay.
Not knowing where these go, but then we can replace these faces if they need to be surfaces that are holding something or running surfaces with ribs. That stiffens apart and it gives it a mating surface. It's just not solid. So now we're going to look at coring this part out.